So now we're going to be talking about some properties. And one vocab word I want to get out of the way is equivalent expressions. So it's just the idea that something like 3 plus 5 is an equivalent expression to 8. So, it's maybe pretty obvious, but this is going to show up in our properties, which I'm going to be talking about. So, there are a bajillion properties, so I'm going to go over them pretty quickly. So, the first 4 we're going to talk about are the properties of equality. So, we're going to start with the reflexive property, which these long words, here. We're going to be starting with the reflexive property. And this states that A is equal to A. So this is probably one of the most basic ones, saying that anything it can be equal to itself. So, 3 is equal to 3, and 4 plus 2 is equal to 4 plus 2. But if we take this concept, we can start manipulating the equation, right? So saying that 4 plus 2 can be equal to 6, and when we get into more complicated expressions, this could be very helpful. So next, we're talking about the symmetric property. So symmetric property, okay? So it's basically saying that if A is equal to B, then B is equal to A. So this is kind of, again, duh. You can flip the equation, doesn't really matter. This basically says that if you have 8 is equal to 6 plus 2, you can write this as 6 plus 2 is equal to 8. Again, very simple, but these are just properties of equation. Next, we have the transitive property. And so this says that if A is equal to B and B is equal to C, if B is equal to C, then A is equal to C. So again, pretty logical, right? If we have 6 plus 9 is equal to 3 plus 12, and 3 plus 12 is equal to 15, then we know that 6 plus 9 is equal to 15, right? So this is just logical again. So now substitution, which I'm just going to abbreviate sub. And it's basically saying that if two quantities are equal, you can substitute one for the other. So if A is equal to B, then in any expression, we can substitute B for A, or vice versa, B for A. So if we have, if we have n is equal to 11, then we know that 4n is equal to 4 times 11, right? And how we can come to this is we know the reflexive property. So obviously 4n is equal to 4n. And then we said, okay, well, if n is equal to 11, then we can substitute the n here. So 4n is equal to 4 times 11. So that's kind of how we came to this conclusion. Next, we have the addition properties. So we have the additive identity. So add identity, okay? And so you guys may be aware of this. I think they've taught us this in previous grades. This basically says that when you add 0 to a number, so A plus 0 is equal to A. Pretty easy. So if adding 0 to A or adding A to 0 is just A, right? Like 4 plus 0 is still, that's supposed to be a plus, is equal to 4 still. And same thing with the minus. Now we're going to talk about the additive inverse property. Additive inverse property. And this is kind of exactly how it sounds. If we have a plus negative a, then it's going to be equal to 0. So if we have 5 plus negative 5, then we have 0, right? Pretty simple. Now let's talk about the multiplication properties. We have more room here. So we're going to do multiplicative identity, which I'm just going to start abbreviating these because my hand's going to get sore from writing everything out. And this basically says that when you have a times 1, it's equal to a. So, if we have 10 times 1, that's still equal to 10. And then now we have the multiplicative property of 0. Start abbreviating, of 0. And so this basically just says that basically just says if you multiply a by 0, you get 0, which again we all know, right? So 8 times 0 is equal to 0. Finally, we have the multiplicative inverse, right? Multiplicative inverse property. So, we saw the additive inverse property, which is just the negative, right? So, what would this be? Because if we multiply 3 times negative 3, that's negative 9. It's not 0, or in this case, multiplicative inverse results in 1. So, how it works is it's a term called the reciprocal. So, if we have a divided by b as like a fraction, and we multiply that by b over a, we get 1. And so we have 4/5 times 5/4, that is equal to 1, right? Because they cancel each other out, right? Because it's going to result in, here, if I take that, this is going to be equal to, when you multiply fractions, you go straight across, you do 20 over 20, which, when you have something divided by itself, it's equal to 1. And now for, I think, one of the more important properties of algebra, the distributive property. So you guys may have learned the distributive property before, but it just says that if we have a times b plus c, or b minus c, but we're just going to go with plus. It works with subtraction as well, but we can distribute the a. So a times b plus c is equal to ab plus ac. So let's test this. So I kind of yapped about different examples using the distributive property, so I just cut it short. So that first one was just talking about how in some cases it might be easier to use the distributive property. So this is a smaller example, so it might take longer. But once you work with really large problems like the one on the right that I'm doing right now, it becomes a lot easier to use distributive property. So instead of me doing 7 times 49, I'm doing 7 times 50 and then 7 times 1. And that's kind of it. Now, 2 key terms that I want to go over are like terms and simplest form. So, what are like terms? Well, let's write out an algebraic expression here. Let's write out some algebraic expressions. So maybe we would have 4x plus 6 minus 11, and we might have, 5x squared plus 3x plus 4 plus x squared, okay? So let's talk about like terms. So every term has multiple parts. As you can see here, we have 5x squared, right? So it's made up of a number. Here, let's do 5x squared here. So it is made up of a number, a variable, to a certain exponent, right? To a certain power. So the number in an algebraic term with a variable is called a coefficient. So 5 is the coefficient, x is the variable, and 2 is the power. So if something is a like term, that means that it has the same variable and to the same power. And so when you're adding these variables, so if I were to have 5x squared, or here actually, let's go over to this problem here. We have two like terms here, right? Because we have 5x squared and x squared. We can't add 3x to it because it's only to the power of 1. And you're like, okay, well what about that 4, right? Well, that 4 is just 4 times x to the 0th power, because anything to the 0th power is 1. So that's a good way to look at it, so you don't accidentally combine a constant. That's what it's called. When it's just by itself or with a variable to the power of 0, it's called a constant. Well, let's work on combining these, okay? How would we combine these? Well, when you add two like terms, you add their coefficients. So this is really 1 times x to the power of 2. So if we were to combine this, it would be 6x squared plus 3x plus 4. And so when we don't have any more like terms or any groupings, it's called simplest form. So this expression right here would be in simplest form. This one here would not be in simplest form because it has like terms, right? But when you combine all the like terms, it is in simplest form. So let's try to get this in simplest form here. So I usually like to look at the variable of the highest power. So this is x to the power of 1. And I'm like, okay, well, are there any other x to the power of 1s? And so there isn't. So we can move this down. So we got 4x. And then we have 6, okay? So 6 is a constant. So are there any other constants besides 6? Yes, there's 11. But I think to avoid any issues in the future, what I like to do is make it plus negative. So instead of subtracting 11 from it, you just add negative 11, which when you're moving around terms makes it a lot easier, so you don't forget the negative sign. So let's combine these like terms. So 6 plus negative 11 is going to be negative 5. So plus negative 5 or minus 5. And so this expression is now in simplest form. So guys, thanks for watching. If you like this content, consider subscribing. And yeah, that's kind of it. If you think I missed anything or you have any questions, feel free to comment. I love feedback. I want to figure out how to make better videos. And if you guys have any other ideas for other content I could do, I'm open to suggestions. Next video, we're going to get more into equations and lines and functions. So, get ready for that. I think it's a fun lesson. So, again, thanks for watching, and peace.